Hello students, and welcome to Cute Theory, or Cute Analysis. So, you can probably tell by now what exactly this theory is about. And I do want to dedicate this course personally to my crush or my love interest. So if you are watching this introduction, please do know that I know that this may be a bit complicated because it will employ some advanced math, but do know that in the end of it all, it's just meant to say you're cute. Okay. So aside my crush, this course is going to be a short one, and frankly, it's just my way, or I just wanted to make it because of a paper that I made just a couple of weeks ago. And so I wanted to make a new theory out of it. So we have this new course in our university. So we are branching out to more than just the human, and of course to more than just the queer community and femboys. We are now branching out to relationships and things like that. I mean, I already discussed in relationship theory, but we are extending to beyond that now. And this theory and its methods can apply to any person that wants to call their crush cute. So, you can probably tell by now about how I'm going about this and what I'm hinting, and all that we want to answer a central question around it all. So if Einstein's theory of general relativity wanted to answer the question of what exactly is gravity, and calculus answers the question of what exactly is change, or set theory discusses what exactly are mathematical objects. So the question we want to oh my god, it's causing a ruckus. So the question we want to discuss, or we want to answer throughout this course, is how do I call my crush cute? However, although you can ask this question and answer it subsequently, you could call your crush by simply going up to them and saying, "Hey, you're cute." Or you can sort of make small talk and then make a smooth segue into calling them cute when you get an opportunity or an opening. However, because we have already dealt with a lot of heavy mathematical machinery and methods and constructs, we can now ask a more elaborate question, or a more succinct or precise question that is related to this. And that question is, what mathematical methods can I use to elaborately call my crush cute? Let me be thinking, oh, Professor, it's impossible. It's impossible to mathematically prove that someone is cute because the definition of cute is subjective. Beauty is in the eye of the beholder. Well, we will step inside the shoes of the beholder, and what we will do is, just like any other mathematical theory, especially set theory, what we're going to do is grab our common sense, open the window, and throw it out. Okay? So what we're going to do is detach the physical or subjective meaning of cute, of what it means to be cute, throw it out the window, and then assign mathematical meaning to cute. And so, because we have assigned mathematical meaning to cuteness, well, although that meaning will be subjective, and we will explore different meanings of what it means to be cute throughout the literature of mathematics, we will ultimately use rigorous arguments that are undeniable, because it is math. Math is undeniable. And thus, call your crush cute. Okay? So that is the central premise of this theory. It is to use mathematical methods and rigorous arguments and proofs to call your crush cute. Okay? So, Alright, so I originally wanted this to be just one video in the Family Expositions on Math, which would be like an hour-long video. Actually, the lecture is already in my computer. I already did it. However, I didn't feel like it was enough. I didn't feel like one video that's 1 hour long was enough to just express how profound this theory is. Okay, so I instead made it a full-fledged course and a full-fledged theory, which I will be fleshing out and teaching to you guys in order for you guys to use these mathematical methods to call your crush cute. Okay, so what will be, or what exactly are the fields of math that we might be encountering inside this theory, or inside this this theory? So the first one is abstract algebra. All right. So we have experienced this a bunch already, especially in femboid theory, with mathematical structures and all that shebang, right? But most notably, we will be using group theory, all right? The theory of groups. We will also be using ring theory, which is an extension of group theory. And we will be using measure theory. Alright. I didn't use ring theory inside my paper, but I do have plans on integrating it into the theory. So ring theory is just an extension of group theory. And of course, we use both group theory and measure theory in that paper that I did, which is labeled the cuteness theorems, six mathematical methods applicable, or 6 theorems applicable to elaborately calling your crush cute. I know that's a long title, but the title is meant to be precise and a good sum up of the entire paper. I will link the paper down in the description below. Okay, so aside abstract algebra, we will be using, if I remember correctly, linear algebra. Most notably, position theory. So think of position theory as a necessary prerequisite to this course. Not really necessary prerequisite, but a sort of suggestive prerequisite. So I suggest you guys study position theory or watch my lectures on those before getting to this course. Alright, and lastly, okay, I'm just gonna put these in triangles, okay? And lastly, topology. Of course. Topology, always topology. You always love topology, Professor Femi. Donut equals mug, funny. But this is a very pragmatic use, and it will come in very handy when we do discuss about, calling someone cute. Now we will be employing a little bit of modal logic. However, that's just going to be for the paper. We're not actually going to be integrating it into our study. Okay, so topology, most notably, algebraic topology. So how exactly are we going to apply algebraic topology? Okay, suppose I were to abstract your crush into a topological space, right? So what we want to do is to study your crush as a topological space under the light of fundamental groups, right? And homeomorphisms. And likewise, in linear algebra, we are going to study your crush as a vector space. Or in abstract algebra, we might study them as either a group, a ring, or a sigma algebra over a set. Or maybe just that set, a measurable set, or a measure space, or measurable space. So there's a difference between measure and measurable space. So yeah. So for abstract algebra and group theory, we will be studying, and if we discuss your crush in terms of groups, we will be considering them under homomorphisms and isomorphisms. For ring theory, also homomorphism, but a ring homomorphism, and ring isomorphism. Measure theory, we will be discussing them under isometry. Okay, isometry. For linear algebra, we will be studying them under linear transformations. Okay, linear transformations, or just transformations. And for topology, we will be discussing them under either homotopies, homologies, or homeomorphisms. Most notably, homeomorphisms. Okay, so these three are the main sort of fields of math that you guys might encounter in this course. So, I hope you guys enjoy this course. It's gonna be a short one, I swear to God, it will be a short one. The first few lectures is just gonna be me discussing about my paper in depth and adding some more after that. So that's gonna be the entire course. Again, a short one. And it's a great way to end this school year. So, Qt analysis. So, again, I hope you guys enjoy this course, and I will see you guys in the first lecture.